Hello, I'm Jeffrey DeSmit. I'm going to show you how to use artificial intelligence in Java. More specifically, I'm going to show you how to do planning optimization, which saves some of our users up to hundreds of millions of dollars per year. Today, I'll show you how to code this school timetabling application from scratch using Quarkus and OptaPlanner. This application, when we click the Solve button, will generate a timetable for us. And these timetables will improve the life for teachers and students because it will take into account the number of constraints that we add to it. With that experience, you can then tackle other use cases, such as equipment scheduling, where we need to assign things such as beds in hospitals to patients. And we want to improve the utilization of those things, which could also be things like CAT scanners or other equipment. You'll also be able to tackle job shop scheduling, where we want to make items, for example, books or furniture or things like that, or cars, and we want to reduce the make span, which is the time to create those items. Again, increasing efficiency of our factories in this particular case. You'll learn about another case you can tackle is vehicle routing. This is probably the most interesting, or at least the most profitable case. This is the case where we have users saving a ton of money and a ton of CO2 emissions, and that's simply by reducing the driving time. So we've seen driving time reductions of 20-25%, which, as you can imagine, on a fleet of tens of thousands of vehicles, makes a huge difference in productivity and fuel and carbon emissions and things like that. Also, bin packing is a typical use case, for example, on optimizing cloud resources and so forth. And a very favorite one, of course, employee rostering, where we're assigning shifts to employees and to take into account their wishes and their desires about their free time and their desired and undesired time off. But today we're going to focus specifically on school timetabling. So school timetabling, in this problem, we need to assign these lessons to rooms and to time slots, right? So for example, we have room A and B here, and we have two time slots here, 8:30 till 9:30 and 9:30 till 10:30. Now there's a number of constraints we need to take into account. In this particular case, I'm only showing some of the hard constraints, which is that these two lessons have the same students group. They're both going towards the 9th grade. In this case, there's only one group of students, one class of students in the 9th grade. It's a very simple school. And we need to make sure that these two lessons don't happen at the same time. The same thing here with chemistry and French. They cannot happen at the same time, not because they're the same grade, they're a different one, as you can see, but because they're the same teacher, both being given by Marie Curie. So of course, that teacher cannot be at two places at the same time. And of course, and the last two here, as you can see, have again the same students group. Right. So these are a number of constraints. Now what we're going to do is we're going to create those lessons and those rooms. We're going to give those to OptaPlanner. That's our problem. And OptaPlanner will then actually give us a solution which adheres to all of these constraints, right? Especially adheres to all of the hard constraints and does its utmost best to adhere to as many soft constraints as possible. So how are we going to build this application? Well, we're going to use, as I said earlier, Quarkus for that and the Quarkus platform. And we're going to expose a REST service. And using Quarkus, we're going to use the extensions REST Easy to expose that REST service. We're going to, of course, use OptaPlanner to optimize that, to find that optimal or near optimal timetable. And we're going to use Hibernate, the Hibernate extension, to store all that data into a normal relational database. Of course, if you build this yourself, you might want to replace certain aspects of this. Instead of a REST service, you might want to look at at pulling from a GMS queue. Instead of a relational database, you might want to swap that out to Hibernate OMG to connect to NoSQL databases and so forth, or any other extension to connect to any other types of databases or data stores. So that's what we're going to do today. So I think that's enough talk. Let's get started. The first thing we need to do is we need to set up our project with a build file. So I'm going to take the easy route here, and I'm just going to go to code.quarkus.io, and I'm going to use that website to generate me a project and a build file. So let's take a look how that works. So this is code.quarkus.io. As you can see here at the top, I'm going to generate a Maven file, and I can of course also choose Gradle, but I'll go with Maven today. I'm going to call this, the Acme group is good. I'm going to create a timetabling subgroup there, and my project will be called School Timetabling. Here we go. Now, of course, we need a number of extensions, right? If you remember from the platform diagram I showed earlier, we want to expose this with REST Easy specifically, and we'll use Jackson for the JSON serialization, right? As we're sending a JSON file to our UI. The next thing we need is, of course, Hibernate. I'm going to use Hibernate with Panache. So Hibernate ORM with Panache to go to the database, which makes it a little bit faster to implement all of this stuff. And the last thing we need, of course, is OptaPlanner. That's the AI part. So let's go down here, and that's over here. We're going to use OptaPlanner, the constraint solver AI, to as we shown earlier, to optimize the timetable. And later at the end of this video, I'll also actually send the score back to the UI to show it there. And the score is something that comes out of OptaPlanner. And of course, we want that to be in pretty JSON too. So we're going to use that JSON binding for the OptaPlanner score classes too. Okay, that's it. These four extensions, that's enough. Let's generate our application, all right? So we download a zip. Let's open that zip file. As you can see, I have it over here, and I can now extract it. So I'm going to extract it to this demo folder over here. And there we go. We can show the files and close this. So what you can see here is we now have a nice POM file, and we have a README file and some Docker and some git ignores already there. We can remove those if we don't like those, and we even can just run it with Maven. The Maven wrapper is even included. So let's open this thing up in our IDE. I'm going to use IntelliJ today, so let me do that. So I'm going to open in IDE over here. I'm going to go to that directory, which is in temp demo here, school timetabling. I'm opening that. Okay, it's opening over here. So here we go. And it's loading. You can see it's loading here at the bottom. There we go. And we have our first application here. So let's try to build that, but before we do that, let's jump into the POM file. So by default, this uses Java 11. I still build with Java 8. I'm kind of old apparently, but I'll just switch to 8 here for me. And then the next thing, of course, is I'm going to, for now, I actually comment out the OptaPlanner part for a minute, as we'll just focus on the domain and the rest and the database first before we jump into the other parts. Let's import these changes and let's open the terminal and let's build this. So we can now do Maven clean install, of course, and as you can see, that works. Well, it's building. Let's see if it works. There's actually a test included in there if you want to take a look at that. There's an example REST file in there also, all right? And of course, you can build this natively too, for people who are interested in that part, which I will show at the end of this presentation. Okay, now let's see what's in here. So like I said, there's an example resource in here already, which if you go to localhost 8080 hello, we will get a return back of hello. So let's try that out. Let's do maven compile quarkus dev. All right, here we go. That's booting up. Let's go to over here. Let me just go to localhost If we go to localhost, we can see the static website here, which is included there. By the way, if you're wondering where that is, that's over here in the resources. That's this index file. And of course, we can now do hello, and we get back hello. And just to show you that this is Quarkus, we can say hello world, and we just go to the over here and we just refresh and we see hello world, right? This is the speed at which you develop in Quarkus. Okay, so time to make some changes. We leave the dev mode on, of course. So the first things first, we're going to need a domain model. So I'm going to add here a new package called domain, right? And remember, we're scheduling lessons into time slots and into rooms. So let's maybe start with a time slot. Okay, time slot class. Here we go. Oh, let me delete that. I need to ask for a new Java class, not a file. So a time slot class. Here we go. What I'm going to put in here is I'm going to give this an ID. Now, I'm going to choose to give all of my objects here just a plain old long ID. Of course, you can use a UUID, you can use a string, or you can probably not use an ID at all if you're not going to a relational database, right? But I want to actually put this all into a relational database, so I'll need an ID. Okay. I'm going to, every time slot, that's basically a time when a lesson can happen, happens on a specific day of the week. Right? I cannot put a date here. Why can I not put a date? Because the schedule repeats every week. So I can just say this is a time slot that happens on Monday, and it will happen this week on Monday, but it will also happen next week on Monday. We're just creating a timetable for 1 week. Of course, it needs to have a starting time, so I'm going to use local time here, start time. And there we go. And I'm going to use, and of course, it needs an end time. So let's add an end time too. Sounds great. For simplicity reasons, all the time slots here will have the same duration. All of the lessons will take the same amount of time. Now I'll need a dummy constructor, an empty well, not a dummy constructor, no arg constructor, because of this being JSON-ified through Jackson, right? And later when I want to create some test data, I will also want this extra constructor here, so I can just create them easily. Let's add some getters. This is Java, of course, so let's just do that. And I also later I'll show you how this shows up in the log if you want to look at what OptaPlanner is actually doing. So I'm going to add it to string here, so that log is really readable. And the key there is, if you want to really easily read those logs, that's a personal hint of mine, is to keep this short. So what I'm just going to do is I'm just going to take the day of week and I'm going to add the start time, and that's it, right? Clean and simple. Okay, that's our time slot class. So the important thing is about these is, besides the ID, of course, is that it's a certain day of week, start time and an end time. So for example, Monday from 9 to 10, or from 10 to 11, right? Okay, next class, next domain object. The next one is the room. The room is much simpler. So a room, we'll give that an ID, of course, and we'll give that a name. And of course, it needs, again, an empty constructor because of the Jackson thing. And it also needs, we'll want a constructor for a test data, which just takes the name. And of course, we want some getters because this is Java. And then for the logging, I would like to overwrite it to string again and just return the name, right? And here we go. That's the room. Next, the next one is the lesson. So let's create a file for the class for the lesson. So we'll be assigning multiple lessons, right? And here's where it gets a little bit more interesting. So first things first, of course. Let's give it an ID. And let's a lesson has a subject, right? Like this is a lesson for math, this is a lesson for French, this is a lesson for Spanish, right? Lesson for English, of course. Each lesson also has a teacher. To keep things simple, I'm going to use the string for the teacher, which is just the teacher's name. Of course, in a more elaborate example, you would actually create a teacher domain class, and you would actually just reference the teacher domain class here. And that's of course all possible. I'm just going to keep it simple here. And of course, we need a student group. That's the class of students that are attending this lesson. And you'll see in the example, I'll really simplify that to simply the grade, the 9th grade or the 10th grade. It's a very small school that I'll show here, but you could just have one 9th grade, the math class or the STEM class, and 9th grade, the art class or something like that. So you can actually split those up. And of course, these classes could actually share teachers who do lessons across multiple students groups, right? Now, on top of this, each lesson needs to occur in a specific time slot and in a specific room. And those are a little bit special, so let's first add those, right? So in a specific time slot, this is when the lesson happens, and this is the room where it happens, right? Now, the interesting thing about these is that these are not known in advance, the time slot and the room. That's actually OptaPlanner's job. That's the AI, the artificial intelligence job, right? So this changes during planning, right? This is actually initialized during planning, initialized and even changes, initialized and even changes during planning, okay? Good. Again, we want an empty constructor. This time it's not just for Jackson. Actually, OptaPlanner will need an empty constructor here too. And of course, we still want the subject, the teacher, and the student group to be easily set for our test data later. So I'm going to create a constructor like this here. Now let's create a bunch of getters for all of this stuff. Here we go. Oh, there we go. And again, I like to have a good toString so I can watch out in the logs what's going on. So what I'll do is I'm just going to return the subject here. Now the problem is that the subject itself is not unique. So for example, the math teacher can actually do multiple, will actually, for the same teacher, might actually teach multiple lessons to the same student group. So just adding teacher or student group won't make it unique either. So if all else fails, let's just add the ID, right? So I'm just going to add the ID just to so we can distinguish between different lesson instances that have the same lesson, the same subject of the same teacher for the same student group, and in that case we can differentiate them in the log at least by the ID. And if you actually look into the application, you'll see that the ID is slightly grayed out there on the bottom left right of each lesson for this debugging purposes, right? This is purely for debugging purposes. In a real UI you would hide that. Okay, looks good. Now we'll have a bunch of lessons, we'll have a bunch of rooms, a bunch of time slots. We'd like to wrap this in a data set which we can just send to the UI in one go, right? So, and also give it to OptaPlanner in one go and so forth. So what I'm going to do is I'm going to create a timetable object, right? And so a timetable object has basically all of the information for one particular school, for one particular tenant, right? So I'm going to give it a list of time slot lists, right? A list of time slots. I'm going to give it a list of first rooms, right? A room list. I'm going to give it a list of lesson list. And that's enough for now. I'm going to give it an empty constructor, again, both for Jackson as well as OptaPlanner in this particular case. And I'm going to give it a constructor where for when I create the test data later on. Okay, and let's add some getters. Here we go. Yep. And on this, I really don't care about the toString because this is not showing up in the logs. So I'm going to leave that out. We had an example resource here that came with the example. I'm going to throw that out. It also means that, of course, I'd better throw out these tests. So let's do that. And let's add an extra package here for the rest stuff. Here we go, for the rest stuff. So now we have our domain objects, and now we want to expose this through REST methods so we can actually see those happening in our browser. So let's create a timetable resource. Here we go, a Java class, new Java class, timetable resource. What do we want to do in this timetable resource? Basically, we want to add a method here, public timetable get timetable, right? And we'll implement that in a minute. And we want to make sure that's exposed through REST. So we're going to add a path here for, let's use dash timetable. We're going to add some producers here. This is purely going to be media type application. Let's first inject it. First take that. All right, okay, we want to have a media type of application JSON, and we want to make sure that anything we get from the service also is JSON, right? So it looks like a good start. One thing's missing, of course, we need a method with a getter. So what I'm going to do here is I'm going to add a get method here. Okay. So now we exposed this timetable thing through REST. It accepts JSON, it consumes JSON, and it's a simple getter, and you get this information back. Now, what do we want to get back here? We're going to get back a new timetable. In the end, of course, this will need to come for the database, but for now, just to see if we get this rolling so far, I'm going to create a dummy one. So what I'm going to do is I'm going to create a dummy time slot. Over here, new time slot for the day of week Monday, for local time of, here we go, of 8:30. Seems like a good start for the first lesson. And local time of up to 9:30. So this is the start time and the end time of this particular lesson, right? Okay, we're going to create a room also. Here we go, new room. Let's just call it room A. Okay, and we're going to create a lesson, new lesson. And this lesson, so as you can see, we need a subject, teacher, and a student group. So I'm going to give this lesson is called the math lesson. The best person to give this, I guess, is probably there's others, of course, in history, but let's go with Alan Turing. And the student group, just call this the 9th grade, right? There's just one class in the 9th grade. It's a simple, small school. So now we need to put this into these timetable. So I'm just going to use collections singleton list of the time slot, the collections singleton list of the room, and of course collections singleton list of the lesson. Here we go. And let's see, this is Quarkus, right? So what we just simply do is we jump here, we refresh, the hello resource is of course now gone. We now here we look for the timetable. When we ask for the timetable, we get our pretty JSON thing back, right? And you can see this is all gone through Jackson, and this is all looking pretty okay, right? Time slot, the ID of course was null because we didn't fill that in, the day of week Monday, and so forth and so forth. Okay. This is pretty ugly to look at, right? Well, it's not ugly, it's not really visual to look at, right? And so the next step is, of course, we want to have a pretty UI interface, right? And we're going to put that here. We're going to put that in this file here. Let's get rid of the default index HTML. Now, I could write you the HTML and the JavaScript here. Unfortunately, when I when I write JavaScript, I don't really like JavaScript. It's not really my language. And it would actually turn this video into an R-rated video, which I don't want. So I'm just going to copy the UI in this particular case, as it's potentially less interesting. So I'm just going to copy in here 3 files. These 3 files are the HTML file, which shows the pretty UI, the JS file, which handles the buttons and so forth. This is using Twitter Bootstrap and things like that. And a logo, because I like showing a logo of OptaPlanner, because that's my project, right? So let's see what happens now. So the REST service, of course, hasn't changed, but if I now go to 8080, you can see I have a pretty UI. Now, what do I have in this UI? As you can see, we have our room here, we have our time slot over here, and it looks pretty okay. We have our first lesson here, Math by Alan Turing, 9th grade. You can see there is no ID here because the ID was null still. This hasn't been in a database or anything like that yet. And when we click the solve button, we get a big pretty error message, of course, because all of that stuff hasn't been implemented yet. We cannot also not just add let's say add a room, let's say add a room D here, submit the room, all that stuff doesn't work, of course. So it's time to actually implement that stuff. So let's go back. The next thing we need is we need to make these things JPA friendly. So let's start with the time slot as last time. So if you go to the time slot, what we're going to do is we're going to first make sure, so this is making them Hibernate friendly, we're going to put them into the database. This is an entity, something we want to put into the database. Of course, anything that goes into a relational database needs an ID, and specifically we're going to use the IDs will be generated on the database, so I'm going to just put that to strategy generated auto here, so we get our database IDs. You could then also add not null annotations and so forth. I like to do that myself, but I'm going to skip that here. So that's for time slots. And now let's take a look at room. We're going to do basically the exact same thing. So let me just copy that because I'm a bit lazy as a programmer, right? So, and of course we need an entity here again, that this is also something that goes into the database. Same story for a lesson. This goes into the database here, and there of course it becomes a little bit more complex, because even though these are all normal properties, the ID is a bit special, but over here you can see there's some red lines already. Yeah, this is not a basic attribute, right? So what we need to do is we need to tell Hibernate, okay, this is a many-to-one relationship, right? Every lesson is assigned to exactly one time slot. One time slot has multiple lessons assigned to it, hopefully not in the same room at the same time, of course. And room, same thing. One room will have multiple lessons, but hopefully not at the same time. And but they could be at the same time temporarily, right? It could be like this in a database for a little bit of time at least. So we've done this, looks good. Now, if we start this up, what we will see, of course, is this needs to go into the H2 database, right? So if one of the things we've added, oh, and I forgot to add that actually. I didn't select when generating the code, I did not select the H2 database. Now, that's not a real big issue, because I can just say, let's take this one, and I'm just going to add the Quarkus JDBC H2, and there we go. Right, we import this. You can see something going on here at the bottom. It kind of woke up and did that. And for that to work, we need to have a little bit of application properties. So the application properties is a file with key value file where we can say where do you set all kinds of things for the extensions. So what I'm going to do here is I'm going to, for the database part, so let's do this, database part, what I'm going to do is I'm going to say, okay, Quarkus.data source db kind is H2. So we're going because we're using the H2 database in memory right now. And then for the username, I'm going to just leave that empty. The password, I'm going to also leave that empty. And the data source JDBC URL is actually, so we're going to use JDBC, which means that this is a memory database, which means that every time we restart, so let's call this school timetabling, all right, and so every time we restart, because of the in-memory aspect here, we will lose all of our data. That's not what we want to do in real time, in the real world, of course, but it's great for this first implementation and quickly developing through new versions without having to actually set up a database server. So I love this approach. Okay, so Hibernate ORM database generation. What I want to do is every time Quarkus here starts up, I want to drop the entire database and recreate the schema in the database based upon the lesson. So you notice here I don't create SQL statements to create the tables or anything like that. Hibernate does all of that for us based upon these entity annotations and specifically also those many-to-one annotations. Also notice that the timetable is not in the database. So the timetable does not go into the database, right? It doesn't have an ID, it doesn't have an entity annotation. We're just storing the time slots, the rooms, and the lessons, those three in the database, okay? So let's take a look what we have so far. If we jump back over here, we refresh this, this doesn't crash. That's always a good thing. You see here no problems here at the bottom. We can see that Hibernate and so forth is active. But are we sure this actually works, that we now have a database schema and so forth? So just to make sure that all works, I'm going to create some test data here. So I'm going to add a new package. I'm calling it the Bootstrap package. And in that one, I'm going to add a demo data generator. So that's something that will generate a bunch of demo data for us. And the way I'm going to do that is I'm going to, first of all, create a method here, which is generate demo data. And here we're going to create, of course, the data to generate. But before we do that, we need to make sure this is picked up. So I'm going to make that an application scope. That basically means that there's only one instance of this. And then I'm going to say, okay, in a transactional method, because of course, when we contact the database, we want this stuff to be transactional, I'm going to observe the startup event. So basically, when the Quarkus application starts up, we want to listen to that, and when that happens, I want to put stuff into the database. All right. Okay, let's put some stuff into the database. Let's do list time slot. All right. There we go. And we're going to create a time slot list. We're going to make it a new array list, right? And in that, we're going to add some stuff like add new. We can go back to our timetable rest method there. We can actually copy paste this, right? The new time slot that we created there. And then we can do that a whole bunch of more times, right? So this is one. Let's do one for room also. And in the end, we need to store all of these. So what we're going to do is, before we jump into the next one, let me finish this. The time slot dot persist method. Oh, there is no persist method on time slots. So how do we get this? Well, we actually used, as you can see here, ORM panache, right? And the nice thing about using panache is that we can now use these classes extend panache entity base. So if we go back to the time slots and we make this extends panache entity base, we're going to get a whole bunch of stuff for free out of the box, right? So I'm going to take this and also apply that to room and to lesson, and now all of these things have been panache enabled. And why do we want that? Because now we can actually call panache persist, give it a list of time slots, and it will store these. And of course, we can add more here. We can make one for 10 o'clock and one from 10:30 to 11:30 and so forth, right? And again, we can do the same approach for rooms, where we call room dot persist room list, right? And we can do the same thing for a lesson, where we do lesson dot persist dot lesson list, right? And that way we can create those. Now, it will take a bit long to actually start adding all of these test data, but I like to really test this with more than just 1 or 2 or 3 or even 4 lessons. So what I'm going to do is I'm going to just copy some stuff over here. I'm going to place these in there. So I'm going to create 10 time slots, 5 for Monday, 5 for Tuesday, first lesson starting at 8:30, last lesson starting at 2:30 and ending at 3:30 in the afternoon. For rooms, I'm going to do the same thing. That's a little bit simpler. I'm just going to create a room list with 3 rooms, A, B, and C. That's the 3 we're going to put in the database. And for the lessons, I'm going to create a bunch of lessons for the 9th grade. So this is a lesson list. I'm going to create a bunch of lessons for the 9th grade, 10 of those. Math, physics, chemistry, biology. You can see different teachers there. But the same teachers are also giving lessons to the 10th grade, so I'm going to add a 10th grade in there. And what you can see here is that now we have 2 math lessons for the 9th grade, 3 math lessons for the 10th grade, but this Alan Turing now is giving up 5 lessons, right? He's giving 5 lessons across the week. And that will be interesting to see because apparently teachers cannot be in 2 places at the same time. So that will be one of the hard constraints that we'll need to take into account later. Same thing for the student groups over here, like the 9th grade, they can only attend 1 lesson at the same time, right? So we actually have 3 hard constraints already: room conflicts, teacher conflicts, and student groups conflict. And later we'll also see some of the soft constraints to actually make their lives better, right, of these students and these teachers. Okay, so that looks good. Now we need to make sure we actually fish that out of the database over here, right? So let's take a look at how we can do that. So we can do a find by ID. So what we can do is we can simply say, we can make this, we can replace this. And what we can do is we can say, okay, return me a new timetable just like before, but I'm going to take time slot because this is a Panache entity, and I'm going to list all of those time slots. I'm going to do room list all, and I'm going to do lesson list all. Okay. And if we now do this, let's make this a little bit cleaner, right? If we now do this and restart over here, what happens? We see all of the rooms, we see all of the time slots, the ones I spoke about, and over here we have all of our unassigned lessons, right? We have those math, so you can see here's a math lesson from Turing, math, and then of course we have all of the other lessons like physics from Curie, history from Mr. Indiana Jones, biology from Darwin, of course, and so forth. Okay. We can, and if we look by teacher, we can see the 5 teachers over here, but we don't know who will teach. We know who will teach which lesson, we just don't know when they will teach those lessons. And we, of course, by group, student group, we can look at them too. Okay, so, and notice how the IDs are now visible in the thing. So each lesson actually has a database ID, which was generated as they were stored into the databases. Great. Let's go back to our implementation. What's the next step? Well, we have, well, I would like to really have these buttons working here, add a room and so forth. This still doesn't work. So what I'm going to do for that is I'm going to add a specific class here. And let's just do room today. So we do a room resource. All right. And so there's a little bit more REST methods. Again, we're going to do produce and consume JSON, so I'm just going to copy that over. This will be called rooms. I'm going to make this transactional. Why? Because all of the methods on here I want to be transactional. And so one of the things there is the add and delete room, right? So I'm going to create a response where I add a room. Here we go. And so we simply do room.persist room, and that's the panache approach, right? And I'm going to return response accepted, the fact that we've accepted that room, and we built that. So we're basically going to return the same response and say, yeah, it's all good. And of course, this is transactional because of that. Now we do need this to have mention that this is a get or a post method. As we're changing data for security reasons, this needs to be a post method, of course. And through a similar approach, we can add a delete and so forth. But I just want to show you, I'm going to skip that for here, but you can see we can now actually add a room, submit a new room, right? And if we refresh, as long as we don't change anything in the code, that thing is there. However, if we change something here in the code, let's add that delete method anyway. So let's do public response delete, and we're going to just get a room ID here to delete, and that's going to be of course a delete method, and the path will contain the room ID, and we're going to here have a path param of the room ID. Okay, and then we're going to just say, okay, room based with the panache thing, find by ID. We have a find by ID here. We're going to use the room ID, and we're going to say, okay, if we don't find it, if room is null, what we're going to do is we're going to return the response status, that the response status is not found, right? So let's take a look at not found here. Here we go, and we're just going to build that. Otherwise, we will of course delete the room. That's a method we get from panache. Let's make sure we do a decent comparison there, and we're going to return the status that the response is okay. The response status will be okay. Okay. Now, as I said, as I showed earlier, if we switch over here to the browser, last time when we pressed refresh, roomd didn't disappear because there were no changes in the code. This time when we press refresh, roomd does disappear because there are changes in the code. And of course, now we can still add roomd, right? That still works. And now we can actually remove rooms too, like room C, room this, and so forth, as I show here. Okay, perfect. It's time to add some artificial intelligence to this, right? Because it's great, we have our timetable, we have our rooms, but we still don't have these lessons assigned, and that's where the magic comes in. So first things first, let's enable OptaPlanner. We go back to the POM file, we throw in the OptaPlanner extension, and as we want to send that to the UI, we're going to also add the OptaPlanner Jackson thing in there. And so what do we need to do? And you can see it's already complaining about a couple of things. Right now, the extension still really likes you to only be used when you have the proper annotations on those classes, and you can read at what the problem is. So let's fix that. The new versions of the extension won't have this problem. So I'm going to make the lesson a planning entity. What does this mean? So first of all, I'm going to refresh IntelliJ, so it actually recognizes planning entity. And why the planning? So why the lesson? That's actually that's a very important question, a very important key concept. These lessons are the things that change during planning. So the rooms, the time slot don't change during planning, but the lessons actually change during planning. They change from where they are now, unassigned, to an actual assigned to a room and to a time slot. So because of that reason, we're going to say, okay, the lesson is a planning entity. Now, the next thing is, of course, what of these lessons will actually change? And like I said earlier, these things change, right? We've annotated them already. So what we do is we're going to just say over here, we're going to say, well, the time slot there, that's a planning entity. That's something, a planning variable. That's something that OptaPlanner can change for us, right? Now, a planning entity always needs a value provider ref, and we're just going to call this a time slot range. It needs to know which time slots can I put into there, right? And it's going to do this based upon this ref to a value provider, which is something that will give me a list of time slots where we can choose one for each of the lessons to put into. That's why we need the time slot range here. And the same problem for room. So for room, we want to say it's a planning variable because OptaPlanner can change it. It needs to change it from null to a good room. And of course, it needs to know where is my list of rooms where I can choose from. So again, we're going to make a room range here. And you'll see a bit later where we actually provide those lists of time slots and those lists of rooms, right? But that's it for this side for the lesson. So that's now planning enabled. However, to give something to OptaPlanner, we need to have this wrapper object, and this timetable is actually it's called a planning solution, and it's actually the ideal thing here. So what is a planning solution? It's basically a list of everything that goes into OptaPlanner, a list of all the time slots, all the room lists, the lesson lists. It's also going to help us provide that list of time slots which we'll need to pick from to fill into these time slot field and every time slot field of each of the lessons, right? So that's this time slot table thing. And in OptaPlanner terms, that's called a planning solution. So let's add a planning solution annotation there. And the lesson list is where it is actually all our planning entities. So I'm going to tell him that this is a planning entity collection, right? A property that has a planning entity collection, right? This lesson list. You can do this on the getters, but I'm using it here on the fields as that's easier. So remember a minute ago that for this time slot list we needed to give that. So what I'm going to say here, that he can choose from that to fill in those planning variables. I'm going to make this a planning range, value range provider. And so the ID I'm going to use is exactly the same one as we had here on the lesson, as here's the time slot range. That's the one I'm going to use here. So now when we give OptaPlanner a timetable where there's a list of time slots, then he will pick all those lists of time slots to put into those lesson time slot fields. We're also going to do is we're going to do the same thing for rooms, right? So then basically any of these rooms that we have in here can actually be filled into the lessons room field, right? Now the difficulty is not assigning one lesson, the difficulty is assigning all of those lessons in a way that they are compatible with each other, right? And that's of course the hard part. That's where it's incredibly difficult to do that. The search paging is incredibly difficult, and humans are actually pretty bad at it, but that's a different conversation for another time. So let's just get this implemented. Now, one more thing. I'm going to build constraints, and I want to make sure that so these lessons are automatically available in those constraints, but the time slots and rooms are not by default. Just to make sure that they are available, I'm going to annotate them with a problem fact collection property, which basically means that these are called facts then, anything that we can use from the constraints. you'll see that once we start implementing the constraint, why this matters. Let me maybe first indeed start with the constraint now that we're talking about those. So I'm going to create a package specifically for the solver part of this. And I'm going to here create a class file called the timetable constraint provider. So that will define what are your hard constraints, what are your soft constraints, what do you want to optimize, what are your business goals, what are your, how do you want to improve your return on investment, how do you want to improve your employee retention, how do you want to improve your service quality and things like that. That all goes into this class as constraints. Now, and of course, you can delegate it to other classes if it becomes too many in one class. Now, what I'm going to do here is I'm going to implement a constraint provider. Okay. Here we go. And that has a single method, the define constraint methods. And for now, I'm going to leave that empty. Leave constraints here, just return a list of empty constraints. Okay, and we have a constraint factory. That's the object that will help us create constraints. But for now, I'm going to say there are no constraints. Problem solved. Okay. Now, let's get back to the timetable. As soon as these lessons in this planning solution are being assigned to rooms and time slots, then that has a specific score. A score means what is the quality of the solution, right? The score actually tells you how many hard constraints are broken, how many soft constraints are broken. So we need to have that in here. And for that, we're going to add a field called hard soft score, a field called score. We're going to use a simple hard soft score. OptaPlanner has many other options here. If you use more levels or if you need to use, if the numbers become bigger and so forth, but this is the simple, easy approach. And we're going to say, okay, this is our planning score, right? So that basically means that OptaPlanner will automatically, if it starts scheduling things, put in the score in this particular field. Okay, so far so good. One more thing we need to do, we need to tell, let's see what happens when we run this. So when we go to the over here, we will see that it probably complains. Let's take a look. No, it's over here. So that's good. It parsed everything, right? Let's scroll to the bottom. Everything's fine. So OptaPlanner now validated that entire domain model, checked the planning solution, checked if the planning provider fits nicely to the time slot range here, and so forth and so forth. Okay, now let's expose that. Let's see this actually work. So let's go back to the timetable resource. What I'm going to do here is I'm going to inject a solver manager, right? So a solver manager for a timetable, and anything and the job IDs there are longs. So this is a solver manager, and let's give it this, and let's just inject it, right? Wire it in. So what we can now do is we can say, okay, I'm going to add a solve method, and that's when we hit the solve button. So let's do that. Public void solve. And when this happens, we're going to call, this is a post method because it will change stuff. We're going to give this the path /solve, so we can just call it. So it nicely fits on that solve button in the UI. And then we're going to say, okay, solver manager, here's something I want you to solve. But I also want to listen. Why? Because as OptaPlanner finds new best solutions, better and better solutions, I want to immediately show those in the UI. So I'm going to solve and listen. So first of all, we need to give it a problem ID. As we're only solving one problem, I'm just going to hard code one here. That's the problem ID for now. And let's maybe put that in constant. So this is, let's call it a singleton time table ID or something like this. Okay. Anyway, What we're then going to do is we're going to do, to get the solution, we're just going to do, okay, get timetable sounds like a good idea. That's where we load the solution from, right? The latest version before it's solved, and then when it is solved, let's call a save method. And of course, we will need to implement a save method now. So let's do that. Okay. So we can add a protected method here to do the save of a timetable. Here we go. So you can, what's the problem here? Oh, no, yeah, of course, we need to actually provide the ID. So let's also, it's actually taking that table ID and giving it to this method. So we need to create a method that returns a timetable, and that does, let's do find by ID or something like this. And let's give it a long ID, right? And that ID will always be this constant now, because that's the only job that we're submitting, right? And now we can actually just call that over there. So what we will do is we'll just take the code from our get method and put that there. And over here, we'll just do return find by ID of that singleton ID, right? So we're just going to rewire that get method into that find by ID. So the loading from the database is pretty much the same, right? We still just load all our time slots, all our rooms into a lesson into there. Game over. Just to make sure that all happens in the same transaction, we're going to make this transactional. If you don't do that, that can actually cause issues, because then the lessons over here, if they're already assigned to a room over time slots, which will happen if you want to do repeated planning, will be pointing to different instances of then these time slot and rooms that are given here if you don't have the transaction annotation. So by making this into one transaction, thanks to Hibernate, these will all be, there will only be one time slot instance on Monday from 9:30, right? Given that there's only one in your database, and that will avoid issues. Okay, so save-wise, what we're going to do there is we're going to iterate through all of the lessons in that timetable. So we're going to ask for the lessons. Here we go, and we're going to just say, okay, this isn't find me the actual lesson in the attached lessons. So JPA. So find me the one that's actually in the database. That's the same as in the database. That's the lesson get ID here, right? So there's the same lesson as the one we have here, but this is actually a detached lesson, and this is an attached lesson. And of course, we need to make this transactional. So what does that mean? Attached means that it's in the JPA context. That means if you make changes to it will be stored. And what we're just going to change in that is the time slot and the room. So what we're going to do is we're going to say, okay, attached lesson, set your time slot. Oh, we don't have setters there. We need to go to lesson for a minute and actually add the ability to set these things. So let's add a setter for the time slot, and let's add a setter for the room. All right, things we were missing. Let's go back. Here we go. We're now going to say, okay, give me your lesson get. So we're just going to take the original lessons time slot, which is still attached. But the lessons are not, because they have been changed and so forth. And we're just going to use that. And then we do the same thing here for room. Here we go. And now we have it saved. So let's take a look at that. So let's see if we have everything, right? When the solve method is called, we're going to submit a solve job. This solve job will load the timetable from the database, and then we'll save it to the database every time it finds a new and better solution. It's going to save all of those lessons in the database, their time slot and their room changes only. Okay, fair enough. One more thing we need when OptaPlanner is solving, OptaPlanner needs to know how long it can solve. There's many various options on how to do that. I'm going to keep it simple for now. I'm going to use the just say, okay, terminate when you have a certain amount of time met. I'm going to put it on 30 seconds. So it basically means that OptaPlanner will keep solving, will keep finding better solutions for 30 seconds, after which it will stop. You can leave it running all the time. You can leave it running until it hasn't found any more better solutions for some time. There's many options there. You can terminate it from another thread, as what you will see later. Okay, back to the code. Here we go. Let's click the solve button. Moment of truth. Yep, it's solving, and it assigned everything to the first time slot in the first room. That's not really a big surprise. Why? Because we have no constraints, so it can do whatever it wants. There is nothing stopping him from assigning everything to the first time slot in the first room. Right? So let's go back. Let's go to the constraint provider. Right? Because in the constraint provider, that's where we allow us to add hardness of constraints. So the first thing we want to add is we want to add a room conflict, where we say, okay, let's do that. Here we go. Create the method room conflict. So it looks good. And what we're going to do is say, okay, given the constraint factory, right? If please select me a lesson, right? From lesson. This is pretty much like SQL. Now you're probably wondering, why isn't this Java? Maybe we can actually do this in, why isn't this just a Java for loops and so forth, where we just get the timetable, we go across the time slots and the lessons and so forth in that timetable. Now we can do that, but it's going to be awfully slow because it won't do things like incremental calculation, indexing, and we want to do all of those things. And more specifically, this constraint provider will allow us to use the power of Drools and Cogito underneath. So we want to take use of those things to actually get solutions faster and to be able to scale out. Right. So with a simple Java, which you can do in OptaPlanner, you will not be able to scale out. With this approach, you will. So okay, let's do that. So I have a lesson here. I'm going to join that with another lesson. All right. But I'm going to make sure that they have the same time slot. So they happen at the same time. Time slots. Okay. And I'm going to make sure that they're in the same room. Lesson get room. So what we now have is we'll basically it's like a query, but it's an incremental query. And we're going to penalize that, and I'll show the penalize in a minute. So what we do is we're going to say, give me a lesson. If we find, select and join that with another lesson, and if they have the same time slot and if they have the same room, then please continue. So then I basically have two lessons here. You can see what this returns. If I would say, what does this return? This gives me what we call a by stream of two lessons, right? So that's the two lessons that are happening in the same room in the same time. And this happens for any such pairs, right? And then we're going to say, okay, that's room conflict. Bad idea. I don't want that. We're going to give that a lesson, a score. Let's keep it simple, 1 heart. And we can even say how that's enough right now. We could even let it depend on the object himself, the weight, or we can even change another weight here, like of hard or of soft, to say, okay, I want to say that this is like this is 8 soft weights. But of course, room conflicts is something that's absolutely not possible, so we're just going to make that a simple 1 hard. Let's see what happens when we run this now. So if we refresh this, we click the solve button again. Let's see what happens now. See? So this looks better, right? Because we no longer have 2 lessons in the same room at the same time. However, this is still an unfeasible schedule, right? Do you notice what's unfeasible is, well, here you can see it. Turing has math giving the 9th grade, but also at the 10th grade at the same time. So if you actually look at per teacher, you can see we still have many conflicts there, right? So let's fix those. So what I'm going to do is I'm going to just copy this, say, okay, I'm going to make this a teacher conflict. I'm going to add that here, teacher conflict. So we now add that thing over that constraint. And the big difference is that we're not going to check if it's an equal room, but if it's an equal teacher. Right. Now this constraint is completely isolated from that constraint, right? This one, the room conflict just checks if there are two lessons in the same room at the same time. The teacher conflict checks if if a teacher has two lessons at the same time, but doesn't mind the rooms at all, right? Completely ignores that. And of course, there's also the student groups. So let's add the student group here too. Let's add those two. Oh, because one student can only have one lesson at the same time. So the same logic there. Here, get the student group, and we can call this the student group conflict. And we go back to Quarkus. We just click the refresh button, we click the solve button, and let's see what happens. We get a different schedule. Okay. Why? Again, it looks good. No room conflicts, but this time there are no teacher conflicts because now Alan Turing gives math. You can see always one room at a time. You can already see what we want to change here. This is not that perfect soft score wise. I'll talk about that in a minute. Let's take a look at the student groups. Looks good. 9th grade has one lesson at the same time, so that constraint is also working very well. Teachers, right? Teachers hate this. This Alan Turing is really hate this schedule because why? He has to show up at 8:30, do a lesson for 1 hour, and then he has to wait for an hour do another lesson, right? So this is really a terrible schedule for that poor guy. Same thing for Indiana Jones here. Lots of gaps between those lessons. That's no fun for the teachers. So let's see if we can fix that. So let's go back to constraints. Let's add an extra constraint, and let's call it the teacher time efficiency constraint, right? So the teacher time efficiency constraint, or team efficiency, and of course we're going to give the constraint factory. Here we go. Now this one is quite different than the others because it's not just looking for conflicts. What we want to do is we want to see if there are two lessons over here and they are sequential, that's a good thing. That's something I want to reward. Or vice versa, if I see a gap in between them, I want to penalize them. But that's a bit more difficult because like the lessons might not always, sequential lessons might not always start at this end and start at the same time. There might be fixed breaks in there, like recess and so forth, or like between Monday and Tuesday when the school closes and the school opens again, of course, right? So what we're just going to do is every time you have two sequential lessons, we're going to reward that. So we're going to say, okay, from, again, lesson. I'm going to say, okay, we're going to join, again, any other lesson, right? And this time, we're not going to look at the time slot. That's the big difference. What we are going to do is we're going to say joiners. If the lesson subject equals, if the lesson, the lesson teacher equals, right? If it's the same teacher, that's the ones we're going to pull out, right? And then we're going to do a number of things with those, and then in the end, we're going to reward those for the teacher time efficiency. And this is not a hard constraint. What that means is that we can break that and we still have a feasible schedule, right? Because if we make this a hard constraint, it's very unlikely that we'll be able to get a schedule which breaks no hard constraints. So we're going to say, okay, this is of a lower priority than these, right? So we're going to, and in this case, it's not just a lower priority with a lower weight, it's really a lower level. So it's not even, we could set these to the other ones to 10 hard and this just to 1 hard, but no, we're going to do it differently. We're going to actually put this in the soft level. And basically, a million or a billion soft does not outweigh 1 hard, right? The difference is basically infinity. Okay, now this alone is not enough because we will have plenty lesson pairs that have the same teacher. Now what we need to do is we need to check that if we have two sequential lessons, that's a good thing, right? So we need to I'm going to do a filter on these. This is something we cannot do with joins. So we're going to use filters, which is a little bit less efficient. If you can do a join instead of filter, always do a join. But anyway, so we have two lessons here, lesson 1 and lesson 2. And what we're going to do is we're going to say, okay, I want you to run a predicate here. And the predicate is, I'm going to ask for the duration between those two lessons. So I'm going to do duration between lesson 1, get time slot. And of course, we're going to do lesson 1, get time slot, get start time, get end time. Let's take end time because that's the first lesson. So the second lesson needs to start after this. And then the lesson 2, get time slot, get start time, right? So that's the amount of time between the first lesson and the second lesson when the first lesson ends and the second lesson starts. If the second lesson is before the first lesson, then between is going to be negative. So we're going to make sure that that's not the case. So we're going to rule those out. We're going to filter those out. And then we're going to check, okay, so the second lesson is after the first lesson, but is it immediately after it? And we're going to basically say, okay, given a duration of minutes of 30, right? If it starts within the next 30 minutes, then it's fine, right? So we're basically saying if the second lesson starts immediately after the first lesson or within the next 30 minutes of that, then we are happy. Then it is two sequential lessons, and that's something we want to reward. That's a good thing. So reward means give me more of that. Penalize me do less of that to OptaPlanner. So penalize will basically hit OptaPlanner in the head when it does that, and reward will basically reward OptaPlanner, give it a carrot every time it does that, right? There's still one bug in here, of course, because these lessons might actually be on different dates. So what we're going to do is we're going to do here joiners dot equal now what we can do is we can make a lambda for this, get lesson get time slot, and then get day of week. We're going to just make sure that they have the same day of week in the time slots when we join them. Okay. That's teacher time efficiency. Let's see if how that works out. We run this, we click the solve button, it still runs, doesn't crash. We get quite a different schedule. You can see it's now changing the schedule. OptaPlanner finds better and better solutions. And if we now look into the teacher thing, we of course have no conflict still, but we see the situation for Alan Turing has improved a lot. He can actually stay home on Tuesday. Same for Marie Curie, she can stay home on Monday, and that's just nice for them, right? So that means much less commute, much less travel, and that's a good thing. And of course, we can see with the student group, everything is still fine. Now, we would like to see how bad is it. What is the hard score? What is the soft score of these changes that we've been doing? So to see those, what we can do is we can actually go into the timetable one, and we have the score here. But the thing is, OptaPlanner calculates the score. And if you start looking at the result here, OptaPlanner sees here runs, here's the solving ended, and it will tell you what the best score is. The minus 60 hard, and yeah, that's a good reason why that's minus 60 hard. Let's actually go back and fix that. If you go into the thing over here, what it will actually do is when two lessons of the same rune conflict, it will also match for the lesson with itself. So when you give the lesson math and there's the other exact same lesson ID of math will also match here, and they of course will have the same time, so it's the same room, and they will actually be penalized. So to make sure that that hard score over here, minus 60 hard, doesn't happen, that we actually get a nice 0 score as we should be, we're going to have to filter those out. So what I usually do is I do less than for the lesson get ID, right? And that's a nice reason to also use a long ID. Works with UID and so forth too, anything that's comparable. And so we're going to use that on all 3 tricks to filter those invalid matches out, right? Where a lesson matches with itself as a pair and that pair gets penalized. Now if we run this again, all right, and we click the solve button again, here we go. With what we will now see, we get the exact same solution because nothing really changed. Those were all, nothing what OptaPlanner could do would minimize those 60 hard constraints, right? They were always just there. But what we look now, if you look at when it's finished, it's still running, but this is the result of the constriction heuristic here. So after the constriction heuristic, it broke 1 hard constraint. And if we wait for the entire 30 seconds, here it is, we'll see that now we have 0 hearts broken, which is exactly what we want. And we got an 11 soft positive score. So 11 times it was able to do sequential time limits. So the next thing we want to do is want to make sure that this score over here is shown in the UI over there. All right. So to do that, we're going to go back to the timetable resource, and we're going to we want to add here in the get timetable, we want to also add that score. So what we're going to do there is we're going to add something called a score manager, which allows us to calculate the score of a solution outside of OptaPlanner, right? So what we're going to do is we're going to add score manager for timetable, and here we go. And then what we can then do is we can get the timetable over here, and we can then say, okay, I have the timetable, score manager, please update the score into this instance you got from the database, because this is coming directly from the database. OptaPlanner is not involved there, and we chose not to persist the score into the database of every solution. So we will just calculate it on the fly every time we give it to the UI. Every time the REST method is called, we'll look what is the timetable in the database, and we're going to calculate the score of that and give that to the UI. And OptaPlanner will not be involved directly, just the score manager will be. So when we add this, which we can do, we refresh over here, we will now also see the score once we solve. Here we go, score still 0. No, we don't. Interesting. Let's go back a second. What's going score manager, update the timetable, and we return that timetable. And we inject the score manager. Let's go back to the timetable over here. We have a planning score here, and we have interesting. Now in the quick start example, this does work. So I must have made a stupid mistake somewhere. My apologies for that. Take a look at the quick start code to see how that's done properly. Okay. Right now we have our solution. So we still notice that the solve button doesn't work correctly. It immediately jumps back to solving while it is still solving in the background. So the way we can fix that is if we go into the timetable resource over here, we can actually add on the timetable, we can add a solver status field just to give that along. So let me just add it here, a solver status field. And the solver status is either that it's going to be solved, it is currently solving, or it is not solving anymore, right? So let's add a getter for that, for the solver status. Maybe the lacking of the score was the problem, the getter here. That could be, because this is indeed, that could be that the lacking of the score here was the problem. Anyway, let's go to the timetable resource and let's actually set that solver state. So the way we do that is we can actually get the solver state by just saying, okay, solver manager, get your solver state of the, are you still solving, yes or no? And we do that before we do any of the other things to avoid a race condition actually. So we can ask the solver manager, are you solving, yes or no, right? And then we can say, okay, on the timetable, I'm going to set the solver status. So we need to go back to the timetable and actually make a setter for that. And let me make one for the score too. Here we go. And then we can do set solver status. And we can give it the solver status. Here we go. And we can now simply go to the UI. And what you will now see is when we click the solve button, first of all, the score is now showing up. So the set score was actually the part that's missing. Didn't go through JSON well. But even as we get new solutions, this button still remains red. So the solver status is now known at the UI. And that's why we wanted to put that into the JSON object too. Now, if we wait 30 seconds, you'll actually see this red button jump to green, because as it goes looking for new solutions, what it will see at some point is that the solver status changed, as it happened right now. Okay, and this is our solution. And you can see 0 hard broken, 11 soft. Now there's a bunch more of soft constraints you can add. There's a few more actually in the quick starts if you look into that. Things such as that to improve the lives of students, which we haven't done so far, right? But to improve the lives of students, you might not want to start Monday morning with 2 math lessons right after each other. So the same lesson right after each other is probably a little bit too much. So you can add constraints to avoid such cases, right? Specifically for the students. Other interesting things for the teacher are the room stability. Such that to make sure that they're always teaching from the same room. They basically have their own room, which is good, so they don't have to move between lessons, and things like that. And you can probably imagine much more from your time in high school yourself, how the schedule could have been improved much better for you. Like, for example, no swimming after lunch and stuff like that. Okay. Now, if you want to try any of this out, try it out, like just follow this video, of course, but you can also just read the guide for this, right? So there's you can find more information on OptaPlanner.org itself, of course, but if you want to specifically try it with Quarkus, take a look at the link below. The guide is there, which has a link to the quick start example, which has all of the code I've shown you here, and also includes things like tests and so forth. So thank you for listening. And if there's any questions, don't hesitate to ask them below this video.